Assalamualaikum dear students. Today we are having Digital Signal Processing Lecture 2 and the topics of lecture are Functional Representation of Signals, Tabular Representation, Sequence Representation, Unit Sample Signal, and we are going to discuss Unit Step, Ramp and Exponential Signal. First topic is functional representation in which the ranges are defined. What does that mean that the ranges are defined? It means for the particular value of n, you are having a particular answer and this is provided to you by the examiner. So the first thing that we are going to discuss is for the value of n when it is equal to 1 or 2. So the value of n when it is equal to 1 or 2, the answer of xn is going to be 4. For every value of n which is greater than 2, the answer is 1 and elsewhere it is going to be 0. So you can see on the below this where I have assigned the values that there is an example given. A lot of examples are given basically. x3. It means the value of n here is 3 and 3 is definitely greater than 2. So x3 is equal to 1. x2, because the assigned value of n is here 2 and for every value of n equal to 1 or 2, the answer is 4. So you are having the 4 as the answer. Similarly, we are having x minus 1. Minus 1 means you are neither having the value of n equal to 1 or 2, nor you are having the value of n equal to greater than 2. So, elsewhere it is going to be 0. So, x minus 1 is going to be 0. Tabular representation. On the tabular representation, you are having two rows. Number one row is of n and the second row is of xn, and we are having a number of columns in which there are examples. So the value of n here is minus 1, and if you can see on the functional representation column, we are having x minus 1 equal to 0. So we are going to continue the same example and the same question. So minus 1, xn is going to be 0. For n equal to 1, xn is equal to 4. Why? Because for every value of n equal to 1 or 2, the answer is 4. For the last column is of, you can see it is of, the value of n is of 4. So for every value of n which is neither equal to 1 or 2 nor it is equal to greater than 2, then elsewhere it is going to be 0. But you can see in the last column that the value of n is greater than 2. It's basically 4. So we are having answer 1. Now this is a little introduction of sequence representation. In the next part we are going to discuss in detail the sequence representation, but just I want to clear it out one thing. In sequence representation, one arrow is mentioned like this, and this arrow is basically representing the origin of the sequence. So taking an example of sequence representation, the origin is at 2. Alright, you can see an arrow below the number 2 which is representing the origin point. Origin is at 2 and left to the origin we are having the answer of minus 1 value of n, and on the right we are having the values of n equal to 1, 2, 3, 4 and 5, and below these values is the answer of x1 which is going to be 4, x2 which is going to be 5, x3 going to be 2 and so on. Now our next topic is some elementary discrete time signals. So unit sample signal is the first signal that we are going to discuss, and there's a rule for it that for every value of n which is equal to 0, it means for when the value of n is going to be equal to 0, the unit sample signal is going to be 1. Elsewhere it is going to be 0. So we have taken an example of xn signal, and we have taken a sequence whose origin is at point 4. It's basically not point 4, it's basically the number 4 having the origin 0. So we are going to have a third signal. The first signal is the unit sample signal, the second signal is the example signal xn, and the third signal is yn signal, which we are going to achieve by multiplying xn with the unit sample signal. So the final expression for yn is going to be when the value of n was 0, which was at number 4. The answer is 1. Elsewhere, all the numbers are 0. So the expression has become 0 except at origin, which is going to be 1. Taking another example of discrete time signal, which is the unit step signal, and we are going to represent it like un. Un is equal to 1 when n is greater than equal to 0, and un is going to be 0 when n is going to be less than 0. So taking an example of xn signal, we are having 4 values 1, 2, 4 and 5, and at the value of 4 we are having the origin. So it means that when n is equal to 0, substituting the value of n in the xn expression, we will have x0, and at x0 the answer is 4, and when n is equal to 1, at x1 the answer is 5. Now we are going to make a third signal, which is the yn signal, and we are going to achieve it by multiplying xn signal with the unit step signal. And we are going to have the expression like this, as you can see on the right of the whiteboard. Yn is equal to 0, 0. Why we are having 0, 0 right here? Because the value of n was less than 0. So the answer is of un is equal to 0. And the value of when n is equal to 0 is going to be 1. When n is equal to 1, the answer is going to be 1. Now coming towards the unit ramp signal, we are going to represent it by urn, and the rule for this signal is that when n is going to be greater than or equal to 0, then the n is going to repeat itself. What does that mean? That when n is greater than equal to 0, you will have the value of n at the place, and when the n is going to be less than 0, you are having 0 answer at the answer. xn is equal to 1, 2, 4 and 5. We are going to take the same example, and we are having the origin at point 4, and on the left we are having -1, -2 values of n, and on the right we are having the value of n equal to 1. So yn is the third signal we are going to achieve by multiplying xn with urn, and now the third signal is 0, 0, 0, 1, because you can see here that the value of n was 0 at the origin. So the number is going to, so we are going to put the value of n at the answer, which is going to be 0, and on the right we are having the value of n equal to 1. So it is greater than 0, and we are going to put the value of n at the answer. Elsewhere it is going to be 0. Exponential signal. Xn is equal to an. If power n, which is on the variable a, is an odd number, then the answer is going to be negative. If the power n is an even number, the answer is going to be positive. That's all for this lecture. If you like this lecture and understand it fully, give it a thumbs up and subscribe to my channel. Also, we are going to discuss classification of discrete signals in the next video, so stay tuned, keep learning, keep smiling, and keep joining. Thank you.